before experienced by a NASA deep space mission, 3 million degree plasma, sporadic solar flares, and delayed communication with Earth. Traveling this close is only possible because of the spacecraft's protective heat shield, the single largest piece of hardware and the most critical to mission success. One slight error in its performance could cause the probe to melt and the mission would be lost.
Parker Solar Probe is actually going and touching the sun. When we actually get to our closest approach, the heat shield on Parker Solar Probe will be at about 2,500 degrees Fahrenheit on the front surface. The back surface is going to be at about 600 degrees Fahrenheit, but then the spacecraft bus will just be operating at a normal room temperature almost. It's a little bit higher, about 85 degrees. The previous missions have been really important for solar science as we study from afar, and we can learn a lot from studying from afar. But the Parker Solar Probe is actually going and touching, almost kissing the sun, so we can learn so much more.
The spacecraft is now ready for flight, but it can't get millions of miles to the sun unless it gets a boost from a specially made third stage by Northrop Grumman.
The Northrop Grumman third stage team specifically designed and built this third stage for the Parker Solar Probe mission. The Parker Solar Probe needs a third stage because even though the Delta IV Heavy is an incredibly powerful rocket, the third stage is what gets it the extra boost to get into its final orbit around Venus and to the Sun.
Parker Solar Probe is the hardest trajectory that I've ever worked on for a couple of different reasons. One, we're flying on the Delta IV Heavy, which is the largest and most complex rocket that Launch Services Program has ever been involved with. And in addition to that, we're flying a third stage that has its own guidance, navigation, and control system on board. So from a trajectory, GNC standpoint, it's like flying two missions